session, we shall discuss sets. Some textbooks will refer to it as set concepts. Some textbooks will refer to it as set theory. Now, this is a broad topic in mathematics, and it has several applications. As we go further down this study, we shall see some of the applications of sets. And we have some mathematicians that did work in this. Notably, we have George Cantor and some other mathematicians as well. Okay, what is a set? What is a set? When we talk of set of books, set of shoes, set of video games, set of tables. What do we mean by a set? We see that a set is a collection of things. Is a collection of things. By things, we mean it could be items, it could be objects, okay? It could be books, it could be, anything at all, okay? Any collection of things is what we call a set. Now, sets could be well-defined or not well-defined. When we talk of a well-defined set, okay, like maybe the set of books in alphabetical order at the JSU library, maybe the set of history books at JSU library, okay, arranged in alphabetical order of their authors. That is a well-defined set, okay. If we talk of a set of students in a school, arranged from maybe first grade, then second grade, third grade, fourth grade, fifth grade, arranged in an order, either ascending order or descending order, then it's a well-defined set. But when we say, if we have a set that is not well-defined, is a set that, kind of, it depends on the user. Like, let's say, set of 3 best movies, that just came out this week, when you look at the movies that came out this week, what you call your best movies might not be my best movies. It might not be someone else's best movies. So that kind of set is not well-defined. Okay, so but well-defined set is arranged in ascending order or descending order. It's arranged in an order, in a clear order, in a defined order. We are going to make our study based on well-defined collection of things, well-defined sets. That is what we want. Okay, well-defined sets. So what do I mean by this? All the sets that we want to be doing, we want it to be well-defined. We want it well-arranged. We want the order of listing to be either in ascending order or descending order in all the topics we will do here. Okay, we don't want to do a set that is might be biased based on users' thinking or based on a user's opinions. So now we are going to look at the ways you can describe a set. Okay, you can describe a set 3 ways. You can describe a set 3 ways, in 3 ways. First way you have by a description. Okay, this is mainly in words, a description in words. You can also write a set. You can say you can describe, or you can write a set. You can write a set in 3 ways. Right? The second one, you can use what we call the roster form. Roster form. Just like when you have your, the teacher has the roster of his students in the class, right? And in that roster, you see students arranged in maybe alphabetical order of their surnames. That is a well-defined set. Okay, alphabetical order of their surnames, and you see the roster. Okay, form. Then the third one is what we call the set builder notation. Set builder notation. Or we can say set generator notation. Set generator notation. Or just set notation. Just set notation. So we are going to look at, we will look at each of these. Then we shall discuss the terms and symbols used in sets. Then we shall watch out for other videos on this. This is like I mentioned earlier, this is a broad topic. We shall do it in series, in video series. So let's look at this, these three things that we just wrote, the three ways you can describe or write a set. If we look at description, let's look at an example. Set A contains the elements Monday. Set A contains the elements. Set A contains the elements Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. If we want to write set A in description form, okay, as description, we just say that set A is the days of the week. Days of the week. That is what we say as set A is. Days of the week. Now, what if we want to put this in roster form? In roster form, what will it be? Then that means that we will write at A, and let me say this, you denote a set with an uppercase letter. With a capital letter, an uppercase letter. That is the way you denote a set. So A is a set of, and I'm going to talk about this now. This is called braces. Braces. We will talk. When you have this, is in your keyboard, and that reminds me. For most of the things we will do in sets, you will learn how to write braces. This is called braces. Braces. Set notation, you use braces. This is a parenthesis. This one is parenthesis. Parenthesis. Interval notation, you use parentheses and brackets. Brackets, this is called brackets. So set notation we are using, or set notation or set builder notation, we are using braces. Then interval notation, you use parentheses and brackets. Now, you've got to use this. And how some of you will, you have this in your keyboard, and you also use this in programming, these braces. You might ask me, how do I draw this? How do I draw it? It's easy. I'm going to show you how to draw it in a minute. Look at how you draw it. You just come, you hold your pencil or pen, you do like this, Okay, just do it as if you're doing an integral form, an integral. Then from here, like this, you do like this. And then if you want to close it, you do like this. And from here, right from here, you just do like this. So you kind of practice it, you know. Do the integral form. Do the integral form like this. Then from here you hold it and do like this. Then here, do like this. Then from here, hold it and do like this. Please, you've got to use this. Now, back to roster form. If you want to do roster form, then A is a set of, you now write Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So you have to, that is the way you do it in roster form. You're listing it, roster. Now, what if the roster is too long, or you don't want to write all these? Yeah, you know. Then what you can use is you use the ellipses. If the roster is too long, just write Sunday. You can write Monday. Then you kind of list the first two or first three, and you put 3 dots. Not 4 dots now, only 3 dots. 3 dots. You put a comma, and you put 3 dots, and you put another comma. Then you write the last 2. You can write Friday, Friday, Saturday. 3 dots. 3 dots, not 4. Ellipses, we shall come to it. That shows its continuation. Continues to that. Now, remember, if you look at this roster form, the elements, you separate them with comma. The elements of the set, we separate them with commas. Then let's write this in a set builder notation. If it is in set builder notation, what is it going to be? We now have that set A is a set of X such that X is a day of the week. You can either use this, you see where you have X and you have a line like that, you have a single line like that, or you can also say, you can also have it like, or A is a set of X such that you can either use this or you use, you can either use this line, single vertical line, or you use the colon. Use the colon. X is a day of the week. Day of the week. So that tells you that it could be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So this is the ways you write sets, and we will, we are going to discuss them as we move along. We shall take we shall take more. We shall do more of roster form and set builder notation more as we move along. All right, now let's list the things, the terms, the symbols that you will see in sets that we're going to see, so that if we do more videos and we use these symbols, you will not be asking, hey, what's this, what's this? So let's get those done now so that we can, let's look at the terms, symbols, and terms used in sets. Used in sets. So let's have a symbol. Let's have our term. let's have the meaning. Term meaning. This tells you that it's going to be long, right? Because I just the first symbol we will look at, number one, let's look at the universal set. We have it like this. We write it like this. It is not U, but some textbooks will write it as U. Some textbooks will write it as uppercase U, but it is actually not U. Not U. Or you can write it like this. This is called the universal set. Universal set. Yeah. The universal set. Right? So it is a set that has all elements under consideration. Two, we have this union. This is union. Union. For instance, if we have A, this B, it means A union B. It's read A union B. A union B. Number three, we have the intersect. This is curving inwards, curving outwards. The union is curved inwards. Intersection or intersect is curved outwards. Intersect. Intersect. And this is A intersect B. Means A intersect B. So anytime you see us write this, it means A intersect B. This is if you have this, okay, braces. This is a brace, you know, set off, set off, set off. That's our braces. Number four, if you have this, you want to say that this is a set off. That's your braces. For instance, if you have A equal to that and you start listing, this means A is a set off. Set off. That's for your braces. Number five, if you have N, if you have N, this is what we call a cardinality. Cardinality of a set. Cardinality. Or you can say cardinal number. Cardinal number. That is a lowercase n. So when we have something like this, n, comma, a. N, comma, a, this means the cardinality of set A. Cardinality of set A. That is the number of elements in a set. Yeah, but we shall give the definitions in another video as we move on. Right now, let us be familiar with the symbols and what it means. Number six, we have a empty set or null set. Phi. This is a Greek word, phi. Right? The term, this is a empty set. Empty set, or you can say null set. null set. It is not 0. No. It is phi, a set that has no elements. Number 7, you can have a P, uppercase P, uppercase P. This is what we call power set. Power set. And if you have P of A, that means power set of A. Power set of set A. Okay, or power set of A. The power set is the set of all subsets. So that brings us to subsets. If you have this, you have this, and you have something that looks like equal to. This is what we call subset. Subset. So if I have A, and I write this, I'll put a line, underline, something that looks like equal, but see, I want to show you something, when you have something like this, this is less than or equal to, you have this as equal to, you have less than or equal to. When you remove one line and you put less than, you have it less than or equal to. All right? This is greater than or equal to. So when you have this now, not C, but something that looks like C, and then you have this. This means it's a subset. That means it's a proper subset or equal to that. We will talk about the definition later on. Yeah. So if you have A, it means A is a subset of B. A is a subset of B. Then if you have just this, okay, this is what we call proper subset. Proper subset. Proper subset. And you have that if you have this, it means A is a proper subset of B. A is a proper subset of B. Number 10, if you have this, you have it backwards like this. This means superset. Superset. So if you have it like this, A superset B, it means A is a superset of B. A is a superset of B. Number 11. Number 11. If you have this, of course, right? Here we kind of say equality of set. Equality of set. This is equal. Right? Equality of set. If you have, this means set A is equal to set B. Means set A is equal to set B. Equal to set B. Okay, now what if you have this? What if you have the subset and you have this? When you have a line, just like when you have a equal, when you have an equal sign and you have a line crossing it, like a traversal line across it. This is not a subset of. Not a subset of. Not a subset of. Yeah. It's not a subset of B. If you have something, A is not a subset of B. It means A is not a subset of B. And you have the other one, not a proper subset of that. 13, just like when you have not equal to, if you have not equal to, when you have this, not equal to, not greater than when you cross that line. I mean, not greater than when you cross the line. Number 14, so you, at least you know what I mean. If anytime you see the line traversal, it means not equal to that. The next one is dot, dot, dot. This is an ellipsis. Ellipsis. It means it continues. We've talked about it. We've mentioned it. Number 15, you have a, let's look at the infinite. Infinity. This is infinity. Infinity. That's the symbol for infinity. 8. Upside, 8 lying down. Number 8, and then lying down. 8 lying down. Infinity. 8 lying down. Uh, 16. What if you have a prime or a complement? You have it prime or complement. Some textbooks will write it differently. Some textbooks write it differently. But this is a prime or complement. Prime or complement. So when you have something like a prime or a complement, it means prime or complement of set A. Prime or complement of set A. 17, you can have this, some textbooks write it this way. It's not E, and some textbooks will write it like a epsilon. Epsilon. Okay, epsilon. Now this is a Greek word. Epsilon. Yeah, in some textbooks you might see it as this. In some textbooks you see it as this. Okay. Now this is what we call a element or member of. Element of or member of. This is if we have maybe that X is an element of A. This means X is an element of set A. Element of set A. Number 18, we can have A minus B. This is a difference of sets. Difference of sets. A difference B. A difference B. A minus B. Difference of sets. Number 19, you can have A times B. A times B. This is what we refer to as the Cartesian product. Cartesian product. A times B. Number 20, when we have X like this, or we have X colon, this means X such that. So this is not exhaustive. And as we go further on in study, if we come across any of these tables we have not mentioned, we shall just include it. So when you're writing these tables down, just make enough space as you go further in the study. Find any other